1.78 times 10 to the negative 10. So that's good. Now, the problem is here it's easy. Here, X is the amount precipitated. And so when we look at this, well, we lost 0.099 out of 0.100. So in other words, this is 99.9% precipitation. Right? Do you see that? 99.9% precipitation or reaction. Over here, S is not the percent precipitation. S is the amount that dissolves. And so in order to figure out the percent precipitation, we have to first calculate the percent remaining. And so when we reset, we don't get the percent precipitation directly. We have to get it indirectly. And so when we reset, we first calculate the percent silver ion remaining. The percent silver ion remaining would be at equilibrium, I need to have 1.51 times 10 to the minus 11 molar over the original amount. The original amount was 0.100 molar. And so this is the equilibrium amount, this is the initial amount. But it's not the initial amount here, it's the original initial amount here. Okay, times 100%. And so this is 10 squared, this is going to be 10 to the minus 9. That's 10 to the minus 8. And so this is 1.51 times 10 to the minus 8% silver ions remaining unprecipitated in solution. And that means that the percent silver ion precipitated is equal to 100% minus the percent that remains. And so in other words, this is going to be 100 minus 0.70. 1, 2, 3, 4, 5, 6, 7, 1, 5, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right. And so what I'm going to get is I'm going to get 99.9999999 849%. The problem with your calculator is this is too many digits to carry. And so this is going to round off to 100% in your calculator. But we don't want that answer. We want this answer. All right, so it's 99.9999, but I want it 100% precipitated. So how much chloride do I have to add to get it 100% precipitated? What is it? You'll never get there, right. That's true. Because when we look at the KSP is going to equal the silver ion concentration times the chloride ion concentration, which is equal to 1.8 times 10 to the minus 10. And therefore, if the silver ion concentration approaches 0, that means the chloride ion concentration has to approach infinity. And so what molarity of chloride do we need to precipitate out with silver? Infinite. Is that possible? No, it's impossible. We'll never. And so the way this looks is like this. This will be the silver ion concentration versus the chloride ion concentration. And the silver ion concentration is going to drop. So as we add more and more chloride, it precipitates. But what's going to happen is it's going to approach 0 asymptotically, like this. And so in order to precipitate out, in other words, in order to make the silver ion concentration 0, we have to go all the way up to infinity, which is not possible. And so what we're going to do is we're going to look, at some point there's going to be so little chloride we don't have to worry about it. And so what we're going to say is this. We're going to have a cutoff here. 99.9% precipitation, we're going to label as complete precipitation. And that's going to leave a residual 0.1% in there, and that 0.1% is going to be minimal, we'll just say, or negligible. And so 99.9% precipitation means we knock out most of the silver here, leaving 0.1% remaining. So less than 0.1% remaining. And we'll have a complete precipitation. And so we'll never precipitate it all out. We're just after 99.9% or more. And that will suffice. All right, this is started to chapter 18. Well, let's take a break and then I'll talk about the lab next. We aren't going to say much because we haven't gotten to chapter 14 or yet.